In 1962, at the height of the Cold War, the United States did something unthinkable. It detonated a nuclear bomb in space. The test was called Starfish Prime, a 1.4 megaton warhead launched 250 miles above Earth. The explosion was so powerful, it created a blinding flash scene from Hawaii, nearly 900 miles away. For minutes, the night sky shimmered with artificial auroras, glowing red and green over the Pacific. But it wasn't just beautiful, it was dangerous. The electromagnetic pulse from the blast knocked out streetlights, damaged satellites, and even crippled communications across the Pacific. Starfish Prime proved space wasn't immune to nuclear war, and it changed how every nation viewed weapons in orbit forever. Before humanity ever reached the moon, NASA had to test the rocket that could take us there, the Saturn V. On April 30th, 1967, engineers ignited its first stage for a full power test at the Marshall Space Flight Center. 5 F-1 engines thundered with 7.5 million pounds of thrust, blasting a flame longer than a football field. The shockwave shattered windows 5 miles away, and the ground trembled like an earthquake. Yet the rocket held firm, no major cracks, no failure. The test proved the Saturn V could survive the incredible stress of launch. 2 years later, that same design carried Apollo 11 to the moon, powered by the machine that once shook the Earth itself. July 16, 1969, a clear Florida morning. From Launch Pad 39A, the Saturn V rocket ignites, 7.5 million pounds of thrust shaking the Earth. On board, Neil Armstrong, Buzz Aldrin, and Michael Collins, 3 men heading for the moon aboard Apollo 11. The journey took 4 days. On July 19th, they entered lunar orbit, and 1 day later, Armstrong and Aldrin began their descent in the Eagle lander.
Tranquility Base here. The Eagle has landed.
At 10:56 p.m. Eastern Time, July 20th, Armstrong steps into history.
That's one small step for man, one giant leap for mankind.
The 2 astronauts spend 21 hours on the lunar surface, collecting rock samples, setting up experiments, and planting the American flag in lunar dust untouched for billions of years. Collins, alone in orbit, circles above, becoming the most isolated human in existence. On July 24th, the command module Columbia blazes back through Earth's atmosphere, parachutes bloom, and it splashes down in the Pacific Ocean. Rescued by the USS Hornet, the crew enters quarantine, greeted as heroes not just of a nation, but of humanity itself. For the first time, we left our world and came home forever changed. November 14th, 1969. Just 4 months after Apollo 11 made history, NASA launched Apollo 12, the second crewed mission to the moon. But seconds after liftoff, lightning struck the Saturn V rocket. Then it struck again. Every instrument went dark. For a moment, it looked like the mission was over before it left Earth. Then astronaut John Aaron gave a single command from Mission Control: try SCE to AUX. It worked. The power came back, the system stabilized, and the crew pressed on. Charles Conrad and Alan Bean landed near Surveyor 3, a robotic probe sent 3 years earlier. They became the first humans to visit another spacecraft on another world. Despite being hit by lightning twice, Apollo 12 completed every goal, proving the first moon landing wasn't luck. The second time humanity walked on the moon, it was pure skill. In 1970, the Soviet Union landed Lunokhod 1, the first remote-controlled rover on the moon. Launched aboard Luna 17, it touched down in the Sea of Rains and rolled onto the lunar surface like a tank built for space. Powered by solar panels and heated by a tiny nuclear unit at night, Lunokhod 1 drove over 6 miles, sent back 20,000 photos, and carried out hundreds of experiments. It survived almost a full year in brutal lunar conditions, proving humanity could drive a machine on another world for the first time. In 1977, NASA launched the Voyager probes. Each carries a golden record, a time capsule with music, greetings, and sounds of Earth. But here's the twist. In 2012, Voyager 1 left the solar system and entered interstellar space. That makes it not only the farthest human-made object in existence, but also humanity's first message drifting between the stars. The International Space Station is one of humanity's most ambitious engineering projects. It hurtles around Earth at about 17,500 miles per hour, fast enough to circle the entire planet in just 90 minutes. That means astronauts on board witness 16 sunrises and sunsets every single day. Built piece by piece since 1998, the ISS is not only a laboratory in orbit, but also a symbol of international cooperation in space. In the early hours of December 8, 2018, a Long March 3B rocket thundered into the night sky over Sichuan, China. On board was Chang'e 4, a mission with an impossible target, the far side of the moon, a place no human craft had ever landed. The rocket climbed through cloud and silence, pushing past Earth's gravity and disappearing into lunar orbit. For 3 long weeks, mission control in Beijing waited as the spacecraft drifted beyond radio contact. Then, guided by a relay satellite called Keiqiao, signals returned. Chang'e 4 was descending toward the von Karman crater, deep inside the South Pole Aitken Basin. On January 3, 2019, it touched down perfectly, becoming the first spacecraft in history to land on the moon's hidden hemisphere. Minutes later, the Rover U-22, the Jade Rabbit 2, rolled down its ramp, spreading its solar wings under a black sky. It powered up, took its first photo, and made history, the first machine to drive across the far side of the moon. Honda. Yes, the car company has just tested its own reusable rocket in Japan. The launch took place on June 17, 2025, in Taikitown, Hokkaido, led by Honda R&D Company, Ltd. The rocket stood 6.3 meters tall, weighed around 1.3 tons, and reached an altitude of 271 meters before landing just 37 centimeters from its target. It stayed in the air for only 56 seconds, but the precision proved Honda's new guidance and landing system works. Honda says this test is part of a long-term plan to develop suborbital reusable rockets by 2029, expanding their engineering expertise beyond cars and motorcycles and into space. Starship's 10th test flight launched August 26, 2025, using Ship 37 and Booster 16. One highlight: Starship deployed 8 dummy Starlink simulators, testing its payload dispenser mechanism, a capability attempted in prior flights but only now executed cleanly. The booster splashed down in the Gulf of Mexico, and the upper stage re-entered toward the Indian Ocean, surviving much of re-entry before being destroyed intentionally on splashdown. There was an explosion in the aft section during re-entry that damaged the heat shield and aft skirt, showing the continued technical challenges ahead. Despite that, Flight 10 is seen as one of the most successful of the test series, a rebound from prior failures and a key step toward Starship's role in orbital and deep space missions.
Starship, landing current startup.
SpaceX launched its latest Starship test flight from Starbase, Texas. The rocket's goal: to fly halfway around the world before splashing down in the Indian Ocean. The Super Heavy booster separated successfully and performed a controlled descent into the Gulf of Mexico. The upper stage then continued east, traveling thousands of kilometers across the globe. During flight, Starship deployed mock satellites, testing its ability to carry heavy payloads into orbit. It reached near-orbital speeds before re-entering Earth's atmosphere and completing a controlled splashdown. This marked SpaceX's 11th Starship test, and one of the most successful yet. It proved that the world's largest rocket can fly long distance, survive re-entry, and prepare for future cargo and crew missions. The flight didn't complete a full orbit, but it showed Starship is getting closer to becoming a reusable global spacecraft.